2 seconds. Hey everyone, Jerry here. Welcome back to another episode of the LlamaIndex webinar series. Today is a fun showcase of just a few really cool agent projects by Zach, Robert, Rickards, and Emma. And these folks have all kind of built some really cool agent projects, and these were all winners of the SuperAGI Autonomous Agents Hackathon that happened a few weeks ago. And so it's cool just to understand kind of the different use cases that it showcases. And it's one of those things where, these days, agents are a very popular use case. Obviously, people have started to understand some of the constraints of when they work and don't work. But at the same time, developers, enterprises are all trying to figure out how to get agents into production. And so showcasing some of these fun use cases is a step towards that as well. And so the format of this will be, we'll have everybody do 10 minutes-ish of demo presentation, whatever you want, and it's pretty flexible, right? It's up to you guys. And then, depending on kind of how much time you take, we'll probably leave 5-ish minutes for Q&A. And then if you guys have any questions, feel free to leave it in the chat. Otherwise, we can move on to the next presenter. And so, cool. Maybe we could start with Zach. Do you want to screen share?
Yeah, sure. Okay, so I brought up, I really just brought up our same presentation that we did, and then I have the code in the back. Oh, is that sharing my N8N, or is that sharing the right thing?
This is sharing the lab. Yeah.
All right, perfect, cool. Okay, so basically, I started building with LlamaIndex, I don't know, 5 months ago, 6 months ago, something like that. I actually met Jerry at the Anthropic Hackathon, and then when this hackathon came up, I really just wanted to build something that, I thought was useful when I start so many businesses, because God, it's just, with AI, you can launch a new business over the weekend, so it's kind of hard not to. And I was always annoyed with all the financial projections and the investment crap and all that stuff that you have to do that nobody really wants to do. So I came up with the idea for Atlas. And don't get me wrong, I couldn't have done this without my team. They're all hanging out in the Discord, I'm sure, listening to music right now. But here's what it is. I'll just play the video real quick. All right, well, basically, the point is we built an all-in-one startup generator that basically takes step by step. It goes through your LLC formation, business info, market analysis, investment plan, marketing and branding, operational efficiency, scalability and growth, sustainability and social responsibility, and then support and accessibility. We only managed to make it to the marketing and branding, not because I didn't finish the other parts, or the operational efficiency of this. I believe we did too. Not because we didn't finish them, but because we basically had one giant N8N API workflow that, we basically just cut it under the wire with all this stuff we were doing. We had 2 of us working on the front end, and then I was handling most of the LlamaIndex stuff. But it's really not that hard anymore ever since I got Claude access. Honestly, I mostly just use Claude on the front end, or Claude for most of the data, and then OpenAI for all the Pydantic responses. But yeah, we really had a fun time building it, and LlamaIndex is one of my favorites. I can show off sort of what it does a little bit, but I did have to tone it back a lot because Anthropic, I reached out during the hackathon for an upgrade to enterprise because we were getting rate limited, and then they were like, no problem, use 5.5 million tokens, by the way. I was like, oh God. But we made a bunch of different integrations that I've actually never done before. I figured out how to read and parse Anthropic Claude's answers, because he actually is really good, it turns out, at giving structured output. He's just not the best at giving you the exact same structured output every time, because for instance, in here, right, I have a do research, which is such a great name for a function that does so much. But essentially this, it generates and asks questions using Claude and LlamaIndex as well as OpenAI. So at one point I have all of the existing data questions prompt, and then I give them the business info, and then essentially OpenAI just says, okay, well, what data am I missing, or what do I feel like I need to look for? And then it searches it, adds it to our vector database, and then I do the same thing with Claude, except I give him a much longer prompt, and I give him every single question that can possibly be asked when it comes to market research. And then I gave him 100K context, and that I think was really a big deal because with 30K he does okay, but like I could run it right now. But the issue is mostly just that what's it called? It isn't it's not that fast because we had a problem where, well, not a problem per se, but because the business plan is generated off the idea and then everything else is sort of generated off the back of each other thing, because once we do the market research, then you from that market research you want to do the investment plan and the scalability and growth and all that. So because of that, then we basically just kind of ran out of time to implement things because what's it called? Oh, it was already an API. There we go. But yeah, so we had a really fun time building it, and I can sort of show you guys what it does. I just need to remember how the heck I launched this thing. Been a minute.
Well, what's maybe just for the viewers, like one thing is like maybe just paint a picture of like the specific use case again. Like what does this generate and what is this used for?
Okay, that's fair. So basically, I could pull up the Notion node, or I could do a lot of things. But essentially, I start a lot of businesses, and for me personally, the hardest part of starting them is all of the crap you have to do at the beginning that nobody really wants to do. You create like a dope idea. You really just want to launch it to market. You don't really want to do the whole, let me call like 500 people, see what they think of this idea. Let me go to product designers. Let me figure this out, how to launch it, what my investment strategy is, where do I get the money from, how do I grow, how do I, all that stuff, right? So basically what I wanted to do, or what we did do, was we built something where basically it takes your idea, and then from your idea, it then will generate you a business plan. It'll teach you how to set up the LLC in whatever state you're in, based on the legal documents, and that's using we actually switched it to Weavy 8, for the vector database. We are going to be relaunching it here pretty soon too, by the way. I forgot to mention that. But after that, it does after the market research, or it does market research, but that actually uses Google and Metaphor API, which is they're like a search engine, an AI powered search engine that assigns a unique document ID to everything that you get back in a result. So essentially, we can constantly grow our vector database with new and more market research every single time it searches. And I gave both Claude and OpenAI that opportunity.
Do you happen to have like a live demo, or this could be in the video too, even if it doesn't have audio, of just like this thing working now?
I don't actually know if I put it in the live demo, but let me see here. All I have to do is run app.main app. There it is. Sorry, you guys. If I have my desktop, you should see how fast that thing would go. This is currently my on-the-go setup.
In the meantime, maybe Dan asks, or I guess it's going right now. Dan asks, do you have an example of the ideal input and the output? Like what would you typically feed in as an input?
So right here, let me go to our Discord again, because inside our Discord, how the heck, get out of here, bar. Yeah, it's fine. So if I actually search in here during the hackathon, I was sending links to the HTML files that it was generating, which actually has, there you go. So this was a business plan for Wicked Burritos. And essentially the intro, or all you put in is, I want to start a business in Los Angeles, or in this case, Detroit, selling burritos, right? Selling the spiciest burritos. So in this case, it generated the executive summary with an introduction, a mission statement, and goals. And then it generated a business description with a type, ownership, location, market research, This is obviously unknown simply because we just didn't format it with the correct thing in the database. And then it comes up with products and services. Customers can customize spice levels and ingredients, and then it does a market analysis. And this is the part that actually really was the part that I had the most fun with, because like I said, it basically learns forever. So when it had the 100K context, it was way too expensive to run over and over again. Like I said, it cost me like $55 over the weekend to just get this crap working right. But it's really cool because it does actual market analysis. So, the nationwide market for spicy Mexican cuisine fast casual dining is estimated at 500 million based on industry data. Significant growth potentially exists with estimated 15-20% annual growth driven by rising consumer interest in spicy ethnic cuisine. Competitive analysis, so like Chipotle, Moe's, and Qdoba. It's nice to see, AI with real data that actually matters. Because usually, like I've met a bunch of AI companies and they always talk about how they can't be sure if their data's right or not, and that just seems silly to me. But then it goes over like an actual business plan that was generated for like the investments and then funding, small business loans or grants, crowdfunding on Kickstarter, Indiegogo, angel investors from the restaurant industry, SBIR grants. And then there's the investment pitch, financial management. And then this was actually a bug from before that we fixed where it would generate a business plan. There's multiple parts of it, but then there's the operational efficiency, inventory management, customer service, AI and HR, and then challenges and solutions with all this. But that was just one of them. I mean, these are all just based on one sentence inputs. So
and this is just like an agent loop that goes around and generates a bunch of stuff and looks up stuff through like Metaphor and other tools.
Yeah, so essentially we had an entire so like this is my N8N that I have set up. But for anybody that's not familiar with N8N, we had an entire N8N setup where it was essentially probably about here. And it was one massive webhook of just inputs that would then go down the list and turn everything into Markdown. And then it renders it all into one big HTML page. So like since then, I have fixed it up a little bit more where it doesn't quite produce like that. Oh, hey, there we go. So we have this server, where is it? We have a server test, I believe. There it is. We move that back up here. So we have this server test right here. And in here, so like we can put, for instance, I don't know, what's a good idea, Jerry? LlamaIndex?
Yeah. Just doing a quick check on time. Maybe we could spend like a minute or so, and then we might pass it to the next presenter.
Yeah, sure. LlamaIndex is a data connector and programming tool for AI, sure. And then I'll just run this real quick to just show you. So basically, it just takes us step by step. And we just built out an API using Fast API with all of this info here.
I see. But yeah, how long does it usually take in terms of like the loop both?
It'll take probably takes like 30 seconds for the LLC business info.
Gotcha.
So you can see the first part and then cut it from there because it will take like probably 10 minutes to generate everything. And that's just due to, the way we get the information and base it all off the one sentence.
That's good.
But yeah. It should hopefully be live soon because we just got the domain hqplan.com. But yeah, same. So it comes back with all that info.
Cool. Okay, sounds good.
Keeps on going down the line.
Yep.
Yeah, thanks for having me.
Awesome. Okay, thanks for the presentation. And then I think next up is Robert.
Yeah, hi. Let me just quickly make a screen share and show you our presentation. Okay, let me know if you can see it and everything is all right.
You're good.
Okay, so basically, Tidy AI, our project, we're helping data scientists. So all of our team are actually working with the data science, like pandas, a lot of data cleaning and all this pre-processing stuff. And we just thought that it would be very cool if it can be completely automated. So just think about it. Instead of like doing all those steps manually, like removing the duplicates, filling the missing values, which is actually a very manual job, you can just do it automatically by giving the data to some web frame, to the data input, and it'll be processed completely end to end. And we thought that it would be actually very cool to implement it with agents. And we created a lot of cool stuff. I'm going to show you later the demo and how it works. And yeah, I'm not sure actually if I should spend time on this business stuff. Yeah, I don't like it. Yeah, let's just jump straight to the demo. So basically, as an input, you just give some kind of a data set. Right now, the web is not working, so I just passed the real data, which was as an input. And it's just a normal CSV file. It has some missing values of type of like string, integer, and so on. And also like some non-values, right? And TidyAI is basically doing all the pre-processing end to end, removing and filling the missing values, right? So basically here on the right side, you can see the agent's history. So first step is basically the initialize data set. It loads the data set on external server to the memory. So basically we have the computer running somewhere with the pandas and Python framework, which has your data inside it. Then it goes through multiple agent steps and it decides what is the best thing to do right now. So basically, it'll take the first sample of the data set, some statistics, and for example, notice that hey, there are many missing values in the country column. Should we drop it or should we just fill it with something else? It makes a decision. It adds this decision to another agent, which decides to write the code. So basically, the agent with the code will see like, hey, there are many missing values in the country column. Here are the most common ones. Make a decision to solve this problem. As an output of the code agent, we receive the code, which is later run. And here you can see like that, for example, it decided to remove some symbols, right? So the price column, the gross discounts or something had a problem. And this is the code which was executed. And here you can see that it basically wrote a function, implemented it on the data frame, and yeah, and this is basically it. Later, this is stored every step. Intermediate step is stored in the SuperAGI storage. And you can like copy the code, download the data frame and each step, and it just does it until you tell it to stop, basically. And for example, one of the steps is like fill in the missing values, convert the date column from, oh, give me a second. Yeah, convert the date column from string to pandas datetime, and yeah, just on and on and on until at some point, this was the input, right? And this data set gets changed to this. So you can see like right now, this is like, I didn't touch it. I just found it randomly on the internet, right? And it filled in the missing values. It decided that Germany is the most often country, and it's better to just fill it with with the mode value. Here we can see that it also did the job with the units solved, probably with a median or something. We can check it out here. And yeah. So this is basically how it works. In the future, we decided that we want to, I don't know if some of you heard, there is like this tool called Julius AI, where you can just type in what do you want to do with your data, and it'll write the code in Python and execute it. So we also wanted to implement this functionality. And yeah, this is kind of how it looks like from the web perspective. In the backend and in the GitHub repository, we made like, let me just quickly show you. We had a few running containers. One container was basically a code execution, which had all of your CSV files loaded into the memory and ready to be executed. So basically, we just send the code there. Yeah, another was like the main one, which was the agents. So yeah, another one was the agents, where we basically have a agent which decided to, here's the current code, right? For example, the error happened and it needs to fix it. And we had like a bunch of those to make it all executable. I think we wrote like 3,000 lines of code in a weekend. And the long story short, if I go to my API usage in OpenAI, we spent like $70 in August for the hackathon. So yeah, it was a crazy journey. We did like a lot of tests and we were very happy where it ended up. Unfortunately, OpenAI didn't give us those $10 they promised, motherfuckers, but it was actually worth, yeah, it was worth it, because I think like this is the idea, which is gonna be on the market very soon. And this is kind of a very interesting way how future is gonna be changed. People will just be basically saying that, yes, I want these to be, for example, cleaned and removed from the data frame, like confirm the action. Do you want it or do you not? And ChatGPT will basically decide what to do, and you just say yes or no. And yeah, this is basically how we see it. Yeah, it was TidyAI. If you want to like follow our team, I'll just send our Twitters right now. And yeah, let me know if you have any questions. I'm working actually on something else, on another project I can show, but yeah, this is basically TidyAI.
This is cool. One question about the so you have like two agents, one like for analysis and the other for writing code. Correct me if I'm wrong. How are you analyzing the data frame? Are you just having the LM like run Python pandas code to like analyze the CSV?
Oh yeah, this is a good question. So we have a little bit more than two agents. This is like a simplification. First of all, we give it the df.info. So basically the output you can get in the basic pandas running, like what is the statistics about the data set. We also give it a sample of the first 10 rows, just to notice if it needs to catch what is the data. So basically, because it needs to like see, for example, that this is a string, but in the info, for example, it doesn't look, something is not relevant, right? So it should be a number, but this is a string. And then we just basically say that it's like a best Kaggle grandmaster, which is doing a data cleaning, and we give it like a few short learning that what it can do. So like discretization, encoding, categorical columns, anomalies, and all of this works if you like just let it run for a few minutes. We have one agent to write the code, one agent to fix the code if it doesn't gets executed. Yeah, does this answer your question?
Yeah, I think it does. The other question was on your page or the TidyAI page, there was like that button on the bottom right that I think was like you can send a message to the agent. Like, what does that do?
Yeah, so right now it doesn't do anything.
Okay.
The idea is that, for example, you get the out of all the operations, right? You waited until it completed something, and now you want to change something. So, for example, you want to just select all the countries from Germany, and you just basically type in here that select all companies, right, from Germany, and it'll just select it with a filter and return you the data frame, or like just show you. Something like this is already implemented in the data looker from Google. You just type in what you want, like the Microsoft AI, something, Copilot, yeah, so many stuff going on, but just type in what you want. It transforms it to code, and this code works.
Sweet. There's a question in the chat that kind of echoes my question too. How do you evaluate the quality of these results?
Yeah, this is a very good question.
Do you have like a metric for doing that?
Yeah, it's very hard to evaluate. So we just truly believe that AI is going to be better and better. So we just trust it. I mean, there are so many prompts that at some point, if it gets something wrong, it'll see the error, because, for example, we also made like a stupid foolproof system that if for some reason the number of rows in the data frame is like reduced by 99%, then just rewrite the code, rewrite the idea. So it's just a simple bulletproof stuff. And ChatGPT is so good that it's able to understand if there are some problems, and we just trust it.
Got it. Makes sense. Okay.
Yeah, I think, yeah, I have some slight thing. I think one of the ways you guys can have a metric is more or less maybe have a metric before and after, so that the user has a sense of what is happening. Because I think in as much as we believe the AI will do a good job, a metric is a good way of evaluating, naively believing, something could happen. So maybe there are a lot of metrics, maybe the mean, standard deviation, maybe the principal component, something, just to know how much information has been reduced or how refined your new data set is. So I think maybe you could look into that later, but good job. Yeah.
Yeah, that's a good point. Yeah, fair enough. Yeah, basically for this, what you just mentioned, you can, at each point in time, you basically, I mean, right now it doesn't work, okay, but you can click on this transformation and you can see the code, and you can see what was the state of the data frame at each of those preprocessing steps. Yeah, and I mean, after the hackathon, I got like a little bit inspired, and let me just quickly show you my next deal. It's a simple extension for Chrome, and all it does is basically, probably most of you have a technical background, and you know that you can get embeddings from the page, so make a semantic search. And I created a simple Chrome extension which allows you to do it like instantly, completely local. So if I search for like science, for example, it'll find me all the mentions of the words. But if I also search for like something which is not a really word, it'll find like the similar ones. And yeah, this is what I'm cooking right now.
Cool. Awesome. Well, thanks, Robert, for your time. All right. Thanks for sharing. And then I think the next project is by Ricard.
Yeah, sure. I will start sharing. And yeah, hopefully you see the screen share. So what I did during the hackathon was in a short sentences developing an autonomous software testing agent. So it sounds maybe like interesting, but I will explain the context and maybe a little bit of background why this exactly. So partially I inspired from my job as a backend developer, and partially from tools like GitHub Copilot or Codium AI. So the good thing about these tools is that they help you during the development time. When you write code, develop your applications, they give you suggestions. But what I thought about was, what about the tools, about the code bases which were written long before these tools like GitHub Copilot existed? How do we ensure that they still get maintained and the quality of code does not disappear? And these were the main motivations why I decided to work on something like that. It would be not only like an additional layer of evaluation that the application actually works, but it would also be like a good way to see where can we improve the code. And here I would like to demonstrate you what you see in front is the diagram of my solution, which I developed during the hackathon. Currently, I would like to focus on the core part of this solution, which is essentially understanding the code, understanding the requirements, and generating test cases, meaningful test cases. Of course, there are parts like running these tests, because due to the fact that this is autonomous agent, it should do everything autonomously. So that's the important thing. But currently, today, especially, I would like to maybe talk about more these like conceptual main things. And the first interesting challenge is understanding the requirements. So if I quickly show you, The requirements can be in very different formats, starting from like basic PDFs, text files, ending with maybe some Jira or GitLab tickets. But the main idea that we have to split these requirements into some usable chunks, so that when we use them, for example, for like querying or understanding which specific features are placed where, we can do it very efficiently, and opposed to just storing everything in one simple document. And a similar situation is with code. So there have been many challenges during the hackathon, and also now further when I continue working on this project is how do I chunk and split the code into meaningful chunks, so that it makes sense both from the perspective of functionality, and also it is like usable, and the model is able to query these codes. So currently what I decided to do for the simple short functions and simple classes is just split them like into classes, functions, and maybe some smaller code structures if the function becomes larger. Now I would like to maybe show a little proof of concept. During the hackathon, I also managed to build a very basic tool with SuperAGI, but as it is not very visually appealing, I would like to maybe show you a proof of concept which is more understandable. So let's suppose that as an input, we have a very, very simple code. This is like two functions in Python, something like calculate square, calculate discounted price. And we can see that here, this function has an error introduced. Maybe it happened by mistake, maybe it was like some bug, but it's important to know that it is there. In addition, we have some functionality, some software requirement specification described here. And again, it was a big challenge. How do we know in which format it would be? But currently, for the presentation, we chose it this way. And we can see that, for example, for the calculate price, we have both input parameters, both outputs, and also a little description of how it should function. Then what the agent does, it is basically all this information is taken from the vector store. I personally use VV8 for this, and I also use the LlamaIndex for the extraction and the parsing of this information. So, and then we pass those both components into the large language model in order to generate ourselves some table with test cases. Why it is important, not only to make it more structured, but also so that a human can easily read them and evaluate that they actually make sense. So, for example, for such simple function like discount price count, we can see that there are like 6 test cases, which, well, they make sense. They have also some expected outputs. They have some description. How should the program behave? And after we have this, we essentially can generate different types of tests. So another aspect why exactly such solution is that we are interested in not only how specific part of functionality works, like specific functions, we are also interested in how the overall general application works. And for that, we need different types of tests, not only unit tests, but also integration, E2E, functional tests, and different tests. So this is like a good basis to generate them. And for example, for this demo purpose, I generated the unit tests using PyTest, and it's based on this table. It gave me a list of sample unit test cases, and we can see that it actually runs. Yeah, this which was initially a surprise for me, but okay, it's quite good that it runs. But and then we can see that this is a test, somewhat test report in the Markdown format. And we can see that some of the tests fail, which is what we would expect from this concrete example, because as we know previously, there was introduced an error in the code I showed. So when we go further, we now need to, the agent now needs to decide what to do with this information. So up until this point, we are provided with the code, software requirements, the test cases, test code, and also the test report. And what would be the logical thing in this case is to understand why does the test report fails? Why are there failing tests? We combine together this test report with our test description and the test cases, which are in Python. And we also provide the code so that it can use it and provide feedback and also bug fixes to us. So my initial idea, which I developed in the hackathon, was just that it prepares a ticket, Jira ticket, or an email to the developers so that, hey, you have an error here. But actually, it makes much more sense if the model is already quite sure that the error is really there, that it can make change and fix the error there. And after we combine this information, we get such like a suggestion of what we need to do. There are quite some steps. Again, as I said, if the model is sure that the error is really there, it could change it. And as we can see, the first point is fix the calculation error. And we can see that the multiplication by 2 is not required there, which is exactly what we would expect from this, because as you remember, in the very beginning, I introduced this error where we multiply by 2, which is exactly the thing that we are interested in. Of course, there are some other interesting suggestions, like maybe splitting the code, formatting in maybe a little bit different way so that it's more maintainable in the future. But I think the main idea is here. So that's about it. If you're interested, I would be happy to share this GitHub repository. You can experiment yourself. There is also like a short instruction. The current demo is a bit tedious because it requires manual intervention, because it's not yet like a fully working SuperAGI instance, but it's like just so that you can test essentially. So thank you.
Cool. One question here is, does the user need to specify the requirement specification for the unit test to generate?
Initially, yes. So what was the idea? That how I would see the classical use case is that we have some legacy code base, maybe, which is a couple of maybe 5-10 years old. And we also have some specification. At least that's how it worked in my company where I worked, is that you have some Word document, very simple Word document, where you have just described how it should function. We add both of these elements together, and then it works further. Of course, there is a question of how we do when the specification is not provided, or maybe it's not as detailed. But yeah, that's the good question, which I would also like to work further on.
No worries. Yeah, I was just curious if you could somehow infer that from like the function signature and then also the like doc string or comments. But
I believe that maybe it's probably possible because, for example, I observed the Codium AI. Their tool is like development, like Visual Studio Code extension, which is capable of such functionality, like suggesting also creating test cases, maybe adding some suggestions on how to improve the code in specific places, so that it has all the context about all the application. Yeah.
Great. And last question here is, what are your thoughts? Like, so this is mostly unit tests, right? Have you thought about writing like integration tests or other types of tests too?
Yeah, that's the like ultimate goal here. So to do it, so like when I have this, I would be able to write unit test, integration, acceptance, C2E, and these are just examples for Python, but that's the idea. What I would like to achieve with this, so that we can see how it how the system works as a whole, and how the system, each specific component of the system works independently. So that's what I would like to support. Yeah.
Cool. Awesome. Well, thanks for your time. And I think for all the presenters, I think if you are able to share the GitHub link in the chat, that'd be awesome. I think the audience is interested. Okay, cool. Well, that said, let's move on to last but not least. Let's have Emma present.
Sweet. Gonna share my screen. Are you able to see the presented screen?
Yep.
Okay, cool. Yeah, so wanted to talk a little bit about evo.ninja. We were also one of the participants at the SuperAGI Hackathon, and basically what we try to build is an AI agent that evolves in real time. So we weren't focused as much on creating some specialized agent which does a particular task, which is general trend currently, but we wanted to do where something which just figures out on its own what to do and how to do, and then just go from there. And how we came about this idea was mainly we were looking at what the current problem space was, where the agents are quite static. So you basically make an agent which is able to do a particular thing. So you input all the functions or scripts or commands that are needed already so that they are available. And then you can type in using those commands, whatever challenge you want to give or the task you want to achieve. And then it's going to use those commands and achieve it for you. But the problem comes in when whatever the command or challenge you input is not being able to complete using the commands that exist. So if it is, for example, a web scraper agent, and then if you ask the agent, I don't know, something related to, let's say, blockchain, then like something to fetch from on chain, then it's not really going to know because its expertise is that. Or for example, if it's a web scraper and you ask it to generate an image, it's not going to generate an image because it doesn't know how to do that. While what we are trying to build here is it actually doesn't matter what your goal is. It's going to be, the agent is going to just understand, learn through online what needs to be achieved, and then achieve that for you. So basically what it does is it starts as agent 0. So kind of, and we actually thought about it also thinking about Matrix, where this agent, those agents basically have a chip in their head, and then they learn this new skill. And then once the chip is out, you basically know that skill on the go, and you can learn whatever and everything you want to learn. So kind of in the similar concept, where it starts with 0, it has no skills, but as you put in the prompts, it figures out how to do it. And once it figures out how to do it, it writes scripts on the fly. So it just writes its own commands, saves it in its ecosystem. If it's a local instance, then it's just local. We are working on building more dynamic and connected agents, but right now focus more on just local instances. So it would just write its own script. And then in future, when you give some commands to it, it's going to first look at its existing scripts and be like, oh, do I know already how to do this thing? If I do, I will use that. If I don't know, then I'm going to write a new script and then put it in my database or in my knowledge base. So that's what it does. It writes scripts on the fly, writes its own scripts, and it is also local first execution, which is actually pretty helpful, given that you don't really need to have the expensive backend architectures in place and figuring out all of that thing, because it just locally does. And then also from security concerns, like if there are a lot of people who are like, I don't want my prompt to be like whatever prompt right now you put in, everything goes to OpenAI and they know what prompts you put in. While if you're concerned with that, this can actually be a pretty good alternative, because your prompts never go to OpenAI. We actually just use the functionality from OpenAI and then bring it in. And I'll just go into it in a second. But first, quickly wanted to show a live demo recording that we have.
Welcome to evo.ninja.
Are you able to hear the audio?
Yeah.
Works. Here inside of the dojo, we're going to ask Evo to look up a funny joke online and then write it to a file named joke.txt. What Evo does first is it thinks of a function or a script, as we call them, that should exist. It's going to use the namespace joke and the description of fetch a joke. The result is bad. It wasn't able to find it. And so what is Evo going to do? Well, it's going to create a script called joke.fetch. It's going to first think about how to write this code. The first thing it's going to do is it's going to use the Axios library to do a GET request on a public joke API. Once it's thought about how to write the code, it's going to write it. As we can see here, it's going to write the function joke.fetch. Here's the source code. And as we look on to our left inside of the scripts category, we can actually see joke.fetch appear. Here we have a simple JavaScript file. This will get run right inside of our browser. We do this using WebAssembly, so it's safe and containerized. Next, it's going to actually execute joke.fetch And the result can be seen here through this preview. Then lastly, it's going to think of what to do next. And to complete our goal, it's going to try to write a file. As we can see inside the scripts, it's already created something here. It's going to write a file. And then lastly, it's going to try to execute this function. And so here's our result from fs.write, which we can now see inside of our workspace. And this has been evo.ninja teaching itself how to fetch jokes online and write them to a file.
Cool. So basically, as I was mentioning previously, so it starts with zero knowledge. And then when you give it the very first prompt, it's going to write the script as we just saw in the demo. And it also saves it locally. And then any future iterations when you do, it basically first going to go check if a function or a script exists already. If it does, it's going to just use that script and then execute the prompt. If it doesn't exist, it will write its own script and then put it in the server or wherever we might choose, or if it is a local iteration, then just locally put it in there so that it can be used in future. And that's how it actually goes and teaches itself. Few of the things since the hackathon we have been working on are primarily around how we can reduce hallucinations. This is pretty big because we don't fine tune, we don't literally give any commands, anything. So it needs to figure out everything on its own. And we are trying to think about it where one, it teaches itself, and because of that, it's able to actually, once it writes its scripts and see if the results were not good. And for it to know results are not good, we are also trying to input the user feedback into it. So you can thumbs up, thumbs down, write a feedback, and which would like become again an input where they can Evo can go and refine that script further. We are also looking into evo.net. So basically the space which I was talking about where it saves its scripts. It can save locally, but we are also thinking about maybe making this shared server where all the instances of evo.net which run around the world can actually start uploading their scripts to evo.net. And then the instances which are running locally would have access to this shared server, and they can get more access to more elevated scripts, which are more robust and where it can reduce the hallucination. Also during the hackathon, we actually weren't able to, we didn't put too much time into thinking about the pre-planning. So mainly you put the prompt, it starts executing. But right now we are working a little bit on the pre-planning phase also, so that it actually first evaluates what is the right way to do it. And then after that, it would go ahead and execute it and then finally evo.net, which I already talked about. And I think the cool thing about evo.net potentially can be where it is not only, so it would have like two contributors, the Evo agent itself who writes the scripts and inputs it. But then also if we start building community around it, we could have this human intervention of developers going in, evaluating scripts, which might be of higher quality or rating them higher, and then kind of making this curated, refined script library, which can be used by Evo. So all in all, just as a quick summary, during the hackathon, we mainly focused on doing this on-demand learning agent. So the agent which can build anything, but locally, more or less. And right now we are focused a little bit on this medium-term goal, which is around code reusability. So right now we are actually doing two things. And the team has been working on the project even since the hackathon ended. One, we are trying to make the agent, individual instance of agent very robust and reliable, as I shared about reducing the hallucination and pre-planning and things like that. And then second, we are also considering on how we can go about doing the evo.net implementation so that we have this code reusability and it doesn't have to write the same script over and over again. And then finally, we are thinking in a long term, actually, a way where we can potentially remove this layer from the agent. So just having this ability to learn on demand be available as an ability to any agent. So anyone who's creating agents out there are like, oh, this I am creating an agent which is amazing at, for example, let's say image generation, but I also want it to have an ability to learn new skills. And if that is the choice, then you can like totally just add evo.ninja agent to your agent. So it would have this additional capability of learning skills on demand. And then additionally, it would also have access to EvoNet. So you would have this whole ecosystem which you can rely on potentially. So that's the direction we're trying to head in. And this was the team which built EvoNet. And then the resources, we have the Discord community, which is where we are actually mainly active. We are looking for folks to try out EvoNet and give us a lot of feedback, or also tell us the kind of prompts you are trying out. That is pretty interesting to us, so that we can achieve our goal of building these robust agents, so that the more you tell us which kind of prompts you're trying, if it's working, if it's not working, as we get that feedback, it helps us to improve the robustness of the agent. And then you can also check out our GitHub. We are very, very actively working on this project.
Awesome. This is great. Super interesting. I think one of the questions from the audience is, are these new capabilities, like the scripts that it writes, limited to functions and API calls, or can it write scripts which augment itself? Like, for instance, like a new way of like doc retrieval, like calling a generative model, or anything else?
No, it's not limited at all. So it can just like, it's learning from the OpenAI model, like LLM model. So it is not limited by existing commands at all. It can just think and generate on its own.
One question I was going to ask is, so what's like the way, like what's the data source that it uses to try to learn like a new function? I noticed in this call, or the example that you showed, it basically kind of called an API, and it knew like the type of API to call. Is there any sort of like retrieval process going on? Does it use like a web tool? How, like for instance, if I'm like a user and I wanted to learn like a new skill over like our own like company data, like how would I go about doing that?
Yeah, so also just caveat, I'm not the technical person, I'm the product person, so I might not like know very detailed answer to it. But overall, I think we are using the file read API. So it has the function of knowing how to read and write file. And then we are also using the web scraping API, so which allows you to give that kickstart in the beginning. And go about. And right now we're working also on figuring out which other potential fundamental APIs we might want to include, regardless of what the use case might be. And then to answer the second part of your question of like, if it is like a specific use case you have and you care about like your company or product and you want to implement that capability, it would fall under you being able to just add that API and then it would pull in from there.
I see. So that's kind of like a work in progress.
Yeah.
Gotcha. Cool. And then I guess last question, which is kind of fun. This is from the audience. A ninja usually has a sensei. So any chance you are adding in some sort of like sensei as a metaphorical object to try to like assist, help reduce hallucinations, or teach a ninja, or basically have like a multi-agent system?
Yeah, I think actually that's a very good question. We were actually thinking about senseis in a terms of making experts within evo.ninja setup. So right now it's super general, and which was the goal of it. But we were also thinking that as we build on the product, we will potentially start making these folders of scripts, and a folder specializes in certain things, which could, I guess, in theory, be a sensei who is expert in those specific aspects, and it can access that if needed. So we would have these like experts or like sub-agents who know certain things much better than other sub-agents. But overall, evo.ninja is able to access any agent within it.
Awesome. Well, thanks so much for your time, Emma. And I think that concludes the showcase of and the webinar. Thanks, Zach, Robert, Ricards, and Emma again for your time, and hope you guys enjoyed it. And the recording will be up shortly.